Hi, I'm Dr. Iman. Welcome to MechCADemy. Today I want to talk about design tables, configurations, and link to property. Imagine a case that you have a part with different versions. For example, this one. For this part, we have different versions, and these versions are the same in outer dimensions, but the thing that is changing from one version to another version is the size of this opening at the center. How can we make all these versions for this part? One way is to make a separate part file for each version, but this is not the most efficient way. So we want to do it in a different way. In this way, we want to make one part file that has all the versions embedded in it. To do this, we want to use the design table. Using the design table, we're going to make all these versions, and these are called configurations. To be able to distinguish all these versions from each other, we want to add a text to each configuration, and we want to link this text to the configuration name. That's where the link to property is going to be used. At the end of this tutorial, I want to take all these configurations to drawing to show you how we can make separate drawing sheet for each individual configuration. In this tutorial, I use an example. The example features a die with 3 different cutouts, as you can see here. The outer dimensions of the dies are all 100 mm, but each cutout has a unique size. I will use a design table to create 3 configurations, each corresponding to a different size as specified in this table. The cutout is a trapezoid defined by 3 key dimensions, A, B, and H. The trapezoid is symmetric about the vertical axis. To help distinguish between the configurations, using link to property, I add a text on each piece, naming it after its configuration. We have size 1, size 2, and size 3. Additionally, I have included a 4th size, and I call it size 4, to demonstrate how simple and effective it is to add new sizes and configurations to the existing ones using design tables. Let's open SolidWorks and see how we can implement this. We are in SolidWorks. Now we want to make the part. Let's change the unit to millimeter, and let's make the part on the front plane. So click on a sketch and click on center rectangle and click on the origin. So it's better to make your part based on the origin. So this is a really good place to begin, and then we make it here. So I'm just going to use a smart dimension. So I'm just going to put 100 mm here, another 100 mm here. So, and then I'm going to extrude boss this in the amount of 2 mm. Now I'm going to create the opening here, go to sketch, another sketch here, and now I'm going to make the opening. So here I'm going to make one line here. This is going to be the B, and then this is going to be like this, and then this is going to be the A, and then this is going to be the last one. So as you can see, here my B is not horizontal, so I'm just going to put a relation of horizontal on this, and the A is already horizontal. Then I'm gonna add some relations to actually make this defined or fully defined. So I'm going to connect the midpoint of the top edge to the midpoint of the bottom edge and then make this vertical. Now I'm going to select this, which is actually for construction. As you can see, it's dashed line, and then click on the origin and click on midpoint. Now I know that my trapezoid is always symmetric with respect to the vertical axis that is actually passing through the origin. Now I'm going to add some dimensions to it. So as you can see, if you go back to the table, for size 1, A is 30, B is 50, and H is 50. I'm going to start from A. This is A is 30, B is 50, and H from here to here is also 50. Now you can see that the trapezoid is fully defined because it turns into black. And you can also see the fully defined message on the bottom. Now we can just cut this. So we go to feature and extrude cut. We can actually just make this through all and done. We have this part, as I told you. One way to do this is to make 3 different parts, one part for each size, but we don't want to do that. We actually want to use design tables and configurations to do that. To do this, let's just change some of these names because we want to use them later. So for sketch 3, I want want to change the name to trapezoid because it's easier to find the dimensions that we want to change. Especially in a complicated model, it's better to change names of different features we have in our design tree. So we actually change this to trapezoid. The next thing that I want to do is to make a design table. To make a design table, I need some variables, and I would call them local variables because I'm not going to make any global variables here. So I'm just going to right click on this and edit a sketch. When you click on each variable, the new window is going to be opened up, and here for the primary value, this dimension has a name. So you can see that this is D1 at trapezoid, and the trapezoid is the name that we chose. So now I want to change this name to A, and then we go to this one and we change this to B, and we go to this one and we change this to H. We have 3 dimensions, and now they have a name, A, B, and H. So I'm gonna exit from this window, and now that we have these 3 variables, I can actually create a design table. There are 2 ways to make design tables. One is to go from insert and then go to tables and click on design table. That's one way. Another way is to search the command here. So here I want to search design table and then click on design table, and this is the new window that is opened up. So here there are several choices that we make. Generally we don't change any of these because we want to, for example, auto create everything. Okay, and generally if we add a new parameter or new configurations, we want them all to be included. Let's just keep everything as it is and click on this check mark. When you click the check mark, a new window is opened up. And in this new window, you can see all the dimensions that you have used for making this part. Okay. For example, this D1 and D2, sketch 2, are the outer dimensions of the square. And then D1 boss extrude is the thickness of the part. And then you can see that we have A trapezoid, B trapezoid, and H trapezoid. I'm going to hold Control key and then click on A and B and H and then OK. So you can see that I have a spreadsheet here that is actually an Excel spreadsheet. You can see here that this is actually Excel. All the menus here are Excel menus. Okay, so you're actually using Excel. You can use formula in Excel. You can do whatever you want in Excel. There are 4 columns. We have the name in the first column, and then we have 3 more columns. So what I want to do, I want just to change this to size 1, and I want to make 2 more sizes. Here I have size 2 and size 3. So we add these values for size 2 and size 3, 20, 40, 40, and 10, 30, 30. I'm just going to go here to 20, 40, 40, and 10, 30, 30. One thing that is important here is that the order of A, B, and H is the same order as you make them initially. If you make or if you apply dimension of B first, then B is going to be the first column. Okay, so be careful about this. So the order is important. So make sure that the number that you enter here is for the right dimension. We have created 3 different sizes, 1, 2, 3. Now we can just click anywhere on the user interface, and this will go away, and you can see that now we have a new message. The design table generated the following configurations: size 1, size 2, and size 3. So if we click on this, it is also good to rebuild the part. If you want to see the configurations, you need to go to the configuration manager tab. So if you go to the configuration manager tab, so again, this is our default. We can just delete it. We don't have to keep the default configuration. But now when you click on size 1, this is size 1, double click on size 2, this is size 2. You can see that now you have a smaller trapezoid, and double click on size 3, and this is size 3. We just made 3 configurations in the same part file. For now, I'm just going to delete this default one. We don't need it. We have this item here. If I click on this arrow, I can see the Excel design table. I can right click on this design table and then edit the table. We do that in case we want to add, for example, a new size. Here it tells us if we want to add rows and columns. For now, I'm not going to do that. Here, I'm just going to add this manually. So size 4, and for size 4, we have 40, 60, 50, right? 40, 60, and 50. So remember, again, everything you do in Excel, you can actually do it here. For example, you can use formula. For example, you can create a new column and create a new variable. But again, remember, this new variable should have an actual dimension in your part. So it's better to create the dimension first and then make the column for it. Okay. But again, you can just use use the formula. You can just populate the spreadsheet as you do in Excel. As you can see, I added a new size, and again, if I click anywhere on the user interface or click on this green check mark, I now have a new size 4, that is going to be actually added to the list of all sizes, and size 4 is actually this size. So far we have made all the configurations. The next thing we wanted to do in this tutorial was to create a text, because we wanted to also cut the text so that it is easy to find which tool is for which size. This is important, especially if you have, like, for example, 20-30 different tools and you don't want to measure each one of them to make sure that you are choosing the right one. So instead you want to actually do some like cutout, like text cutout or engraving on each part so that you can easily pick the tool that you want. To do that, we want to use link to property. The first thing I want to do is that I want to go to size 1, and then I'm going to click on the feature manager design tree. I want to actually create a new feature, and that feature is going to be my text. So I'm going to create a sketch on this face, sketch, and then I want to create a line for my text. So here I'm just going to use the center line, and for the center line I'm just going to go from here to here, from one side to the other side, and I want to make it horizontal, and I want to add a dimension here. The dimension here is from that line to the bottom edge. I'm just going to put 10 millimeter here for now, and then I'm just going to add a text here. For curve, I'm going to use this line here. If I write a text, it will just write the text on this line, but I don't want to do that. I want to use a specific text. So for each size, I want to link this text to the configuration name. The configuration names are size 1, size 2, size 3, size 4. This is very easy to do. So what you need to do, you need to go to this button, link to property. So click on the link to property and then go to property name. Which property you want to link to? You can see that there are so many properties. The one I want to choose is SW, configuration name. Click on the configuration name and click OK. You can see that automatically size 1 is entered here. The location of this is not good, so I'm just going to center it first. I also remove this check mark from use document font. I want to change the font. I have found that 2 fonts are pretty good when we want to do laser cutout. One of them is Cooper and the other one is Gill Sans or Gill Sans. Let's just go with Cooper and then use Cooper Black. For the size, I'm just going to change this to 40, and this is actually the text I have. Also, just to make sure that I have enough space between them, because remember, when you want to fabricate this, if you're using laser cut, we have the laser diameter. A good number for a laser diameter, for example, is a 0.3 millimeter, but again, you need to consult your machine shop to see what's the laser diameter. You want to make sure that when we cut with laser, we still have some material left. I'm going to use these 2 options to separate the letters a little bit more. So here I can stretch the letters, and then here I can make the letters farther away from each other. So 120% is good. It is your choice, so you can actually just use whatever number that you feel comfortable with. So let's just use 120 here and 110 here. I have the text here, and it is actually linked to property. So now what I want to do, I want to use the extrude cut. I'm going to use the extrude cut, and this text is already selected. Now the extrude cut is going to be actually through the text. So here, because there are different curves here, for example, E has this island at the center, it asks us what are you gonna do. So we can just select the bodies and then body 1 and then do this. That will just cut the entire thing, and as you can see, it also cut that like additional piece for E. It doesn't make sense. We cannot have an island without any connection to the mainland actually here. You can see that we just added size 1. The nice thing is that because we use link to property, this text is going to be updated for each configuration to the configuration name. However, sometimes you will see an issue like this. Let me show you. If I click on size 2, I don't see actually the text here, or if I click on size 3, I don't see the text here. So the issue for that is because we just created the cut extrude for this configuration. If I right click on this cut extrude and then go to configure feature, a new table or a new window is going to open up. and you can see that this feature is actually suppressed for size 2 and 3 and 4. So just to fix this issue, just remove the check mark here and apply and OK. Now if I go to Configuration Manager tab and double click on size 2, I can see that size 2 and then size 3 and size 4. Beautiful, isn't it? We have done a lot of things. To make sure that we don't lose them, let's save this file. So we go to save, and part 1 maybe is not the best name, so let's just change this to die and save. Just for fun, I want to add a new variable to our design table. Let's just go back to size 1. You can just do it for any of the configurations. I'm gonna add a dimension to a sketch 3. So I'm just gonna right click on the sketch 3 and edit sketch. In this sketch, I have this dimension here that I use for the distance of this construction line to this bottom edge. Click on it, and now you can see that this dimension has a name, D1 at sketch 3. We can change it, but for now I'm just going to keep it as it is. But I need exact name because I want to add this to my design table. I'm just going to select this and Control C because later I'm gonna need it. So I'm gonna exit from this sketch, then go to Configuration Manager tab, right click on Excel design tree, and then edit table. Here on edit table, I want to add a new column. So this new column is going to be that distance. So click on this and Control V. Here now you can see that this is D1 sketch 3, and for D1 sketch 3 I'm just going to use, for example, 10 for here. I'm just, again, this is something that we do in Excel. So we can populate like this, and then all those cells are going to have the same size. So this is size 1 and 2 and 3. And then for size 4, I want to use 5 as the distance. I have a new column with a new variable, and when I click on this check mark, now all those configurations are going to be updated. So for size 1 text is 10 millimeter distance from the bottom. Size 2, and let's just rebuild it as well. So this is size 2, size 3, right? And then let me just rebuild everything here. Let's take a look at size 4. For size 4, you can see that it actually changed the location of the text. One thing that I want to mention here is that we also have configurations and design tables for assembly, but that's going to be another video. Here, I'm only focusing on using design table and configurations and link to property for a single part, not in assembly. If you have an assembly, you can actually make configurations to create different positions of different parts with respect to each other and so many other things. Now that we have actually made all these, let's make drawing for all these parts or all these configurations that we have in a single part. Let's go back to size 1 and then again rebuild it. Here I'm just going to go to make drawing from part. For the sheet, I have already created one template, which is actually a MechCADemy sheet format. Click on the sheet format that you have and then open. So this is the MechCADemy sheet format. I'm going to just bring the front. So you can see that this is actually the front. Now this is size 1. I don't want other views because there are 4 different sizes. I'm just going to make 3 more tabs here in the drawing. Right click on sheet and then copy, and then here again paste after selected sheet. So now I have another sheet. To make another tab, I can also hold Control key and drag this sheet to a new one, and now I have sheet 122, which is actually an exact copy of that. Another one, again, I can just do this. I have 4 sheets that are exactly the same, right? All of them are size 1. I want that each tab has a different size. So I'm just going to change this to size 2, change this to size 3, and change this to size 4. And this, as you know, is also size 1. Okay, now this is size 1. It should be size 1. Now I'm going to go to size 2. The tricky here is that you need to click on the view and then go to reference configuration and change this to size 2. Go to size 3, click on the view and change this to size 3. Go to size 4, click here and change this to size 4. So now you have also the drawings for all the sizes or all the configuration. You might think that this might not be the most efficient way. Why can't we just bring the part into the drawing and it will just automatically create all the drawings for all the configurations on different tabs, but it is unfortunately not possible in SolidWorks. In fact, it is possible, but it is not simple. You need to write a macro, you need to write a code to do that. Okay, so this is actually the simplest way to do it. I want to end this tutorial by showing you an actual part that I have designed using design table configurations and link to property. So here you can see I have several configurations. Here, if I go to the design table and then edit the design table, you can see all the configurations that I have on this model. You can see there are actually several rows that I have, and for each row I have all the dimensions that I have defined, like this is A, B, H, and I also have some other dimensions. You can see, for example, this is size 01, this is size 26, this is size H911. This project is related to a bigger project that is called High Granularity Calorimeter for Compact Muon Solenoid at CERN. I hope you enjoyed it. I will talk to you soon in the next tutorial. Have a good day. Bye.